Okay guys, today, hello. This is a session for the grade 9s, okay? Today, later on, or at least after this session, but a little bit after this session, because I'm gonna have to need a break after this session. This session is gonna be an hour. We are going to do grade 9 algebraic expression. This is session 2. We did session 1 yesterday, so I'm doing part 2 of algebraic expressions for the grade 9s. All right, so after I'm done with this session, which will just be an hour, I'll take a bit of a break, then I'll jump on. I think for the remainder of today, I'll be focusing back on grade 11, because earlier on this morning I focused on grade 10. I'll be focusing back on grade 11. We'll be doing we'll try and do some functions later on with the grade 11s, and we'll try and do some geometry as well, geometry with functions. But for now, allow me the space to be able to do this grade 9 session again. We started with the grade 9 session. We started off with the grade 9 session yesterday on algebraic expressions, and so we are going to take that up, continuing on. Grade 11, what time? I'm not so sure, Ed, about what time, but like I said, I'm going to have a session now with the grade 9s. It will be for an hour, and then after that, we'll have the grade 11 session. We'll see the time, guys. You're just going to have to watch out for the live, honestly speaking, because the time is not really mine. You're welcome, Johnny. So guys, let's proceed. Grade 9s, we started yesterday. We looked at algebraic expressions. We did all sorts of things yesterday, and I'm hoping that session was very fruitful. I haven't posted the session up in the YouTube channel, but I'll be doing so during the course of today, so that you can review that session and you can also take it in. But today we'll continue on from where we left off, because where we left off yesterday, we left off at a very interesting place, and I'm hoping that you guys were actually really able to appreciate that place that we left off with, because the way we left off, we were looking at like and unlike terms, and we looked at this problem, for instance, where we are multiplying negative 3x squared plus 4x cubed y. And what I wanted to emphasize through this problem, most of you were able to get this answer. What I wanted to emphasize was this idea of SNL, this idea that I seem to always promote in my live sessions, especially when I'm dealing with multiplication of 2 terms, 3 terms, call it what you want. So negative 3x squared times 4x cubed y, when we multiply these two, guys, very importantly, we always, whenever we're dealing with multiplication, we must apply this thing here that I tend to really promote, which we call SNL. We multiply firstly the signs, then after multiplying the signs, we multiply the numbers, then after multiplying the numbers, we multiply the letters. And we must remember this one thing with the signs, that what we learned in earlier grades, very important, that a negative times a negative and a positive times a positive, an even number of terms that are the same multiplied together, they give us a positive. Okay? But then if we have different signs multiplied together, that give us a negative. So this idea here needs to be very solid, because when we are multiplying two things, we need to always make sure that our sign is 100% accurate. Two numbers. I mean, guys, if we are multiplying the coefficient, okay, together, all we need is to make sure that our calculator is working very well. It can function, so that if we don't know off by heart how to multiply two numbers, then we know how to multiply two numbers using a calculator. 3 times 4 is very easy, it's 12. And negative times a positive with the sign is negative. Then lastly, our letters, meaning our variables. When we are multiplying variables, we need to remember the laws of exponents, okay? The laws of exponents are very important. What are we doing now? We are doing grade 9 algebraic expressions. It's the second session from yesterday. We are continuing where we left off. So x to the power 2 plus 3. So for instance, when we are multiplying same bases, there's x squared, there's x to the power 3. Whenever we're multiplying same bases, what do? We keep the base. So x we keep, then we add the exponents, 2 plus 3, which gives us 5. All right, so that's very important. Okay, so for the letters, the laws of exponents, we need to remember them very well, especially for multiplication. Remember, if the variable is different, then we keep that variable as it was originally. So the answer here is negative 12x to the power 5y. This is grade 9, guys, grade 9. Then we look at addition of terms. These terms, are they like or unlike terms? No, they are unlike terms. So these unlike terms, we cannot do anything, guys. They are not like terms, so the answer negative 3x squared plus 4x cubed y is equal to negative 3x squared plus 4x cubed y. We can't do anything with that. Let's look at division. When we are dividing algebraic expressions, so here 4x cubed y, this line stands for divide. All right, so when we are dividing, we also divide using sign, number, letter. When we are dividing, especially if it's a monomial over a monomial, we must first consider the sign. So the top expression is positive and the bottom expression is negative. A positive divided by a negative gives us a negative sign. 4 divided by 3, all right, is still 4 over 3. Then the letter x cubed divided by x squared. When we are dividing same bases, we must remember the laws of exponents as well. We keep the base, as Sivio says in the comment section, and then we subtract the exponent. So that's why we have x to the power 3 minus 2, which gives us 1. Okay, and obviously that 1 can be written there, or it can be made to remain invisible. Whether it remains invisible or it is written, it still shows its existence because there's a variable base that is there and it is awaiting its presence. Then y has no variable that is the same as it is, so it remains and it stays visible in the answer as just y as it was. So when we are dividing, guys, we need to remember the division of the sign, the division of the number, the division of the letter. And like I said, with the signs, we just need to remember what we know about division, because what we apply for division and multiplication where signs is concerned is the same. For numbers, please guys, when you are dividing numbers, just always check if there's a highest common factor. I mean, your calculator is also there for usage, because if you take 4 over 3, you put it in your calculator and say 4 divided by 3. You see, this is the interesting thing about, especially this scientific calculator. You say 4 divided by 3, you see, you get the answer. It's 4 over 3. Hence, I am writing the answer as 4 over 3. It stays like that. But if it was another number where there's factors and it can be simplified, your calculator can simplify for you. For the variables, please guys, laws of exponents as they apply to division for same bases, we keep the base, we subtract the exponents, and remember it's 3 minus 2, right, in this case, because at the top the 3 is there. I think in grade 8 you guys learned that the lowest exponent goes to the highest exponent and subtraction happens there. All right, and that's very important because that helps us avoid this negative exponent in our answer. So wherever the highest exponent is for division, that is where the other lowest exponent goes to and gets subtracted, so that we are left with a positive exponent in our final answer. I think that was making life very easy for our grade 8 last years, because we did not do negative exponents in grade 8 last year. Then for subtraction, again, we must remember if they are unlike terms, guys, 3x squared and 4x cubed y, these are unlike terms. But because we can see that there's a sign there with a bracket, then of course we need to resolve the sign there. So a negative times a negative gives us a positive. And basically we cannot go on any further. We can't add these. These are unlike terms. We can't do anything, all right? Bananas and oranges stay as bananas and oranges. Bananas and oranges, basically, if there are 3 bananas and there are 5 oranges, finally, when we add them up, we say there are 3 bananas, there are 5 oranges. They are separate and apart, but obviously they are as they were in the beginning. So in the same way, we have that. So guys, This is what we looked at last time. This was what we looked at towards the end. There were many more other things that we looked at, but if you want to check that out, when I do upload the video on my YouTube channel, please go and check out the full session so that you can get the full extent of what we spoke about yesterday. Right, moving right along, this is what we are going to check out. I want us to look at the following. Okay. Whenever two monomials are multiplied. Okay, let's look at case scenario number 1. So I'm going to say case 1. Whenever two monomials are multiplied. So here is a monomial. 5x squared multiplied by 3xy. Okay. So 5x squared multiplied by 3xy. Whenever two monomials are multiplied, 5x squared is a monomial, 3xy is a monomial, but together when they are multiplied, we know that this would be regarded, all of it, as a monomial. Right? Now with multiplication and division, guys, whether the terms are alike or not, multiplication happens, division happens. It's just addition and subtraction that seem to have a problem with unlike terms. Unlike terms for addition and subtraction does not happen, but multiplication and division for unlike terms, it happens. So, very importantly, 5x squared times 3xy, we must know the following, that multiplication does happen, and when we do multiply, we use SNL, sign, number, letter. So yes, I agree, these are unlike terms. This is 5x squared, this is 3xy, but multiplication can happen using SNL. So when we multiply, guys, the sign, this is a positive number, this is a positive number. What is a positive times a positive? So our sign is positive, right? Next, the number. This is 5, this is 3. What's 5 times 3? It is 15. The number is done. The letter, x squared times x. What's x squared times x? Obviously here in this situation, what do? We are multiplying same bases. So what do? We keep the base and we add the exponent. What exponent is there? There's 2. What exponent is there? That's 1. What's 2 plus 1? It's 3. The y variable, single, has no partner. So therefore the unpartnered variable stays as the unpartnered variable. So our final answer, in other words, is 15x cubed y. It's as simple as that. So whenever two monomials are multiplied, whether they are like terms or not, the show must go on. Whether they are like terms or not, the show must go on. Multiplication happens. What do we do when we multiply? We use SNL. Let's look at case scenario number 2. Whenever two monomials are divided, whenever two monomials are divided, whenever two monomials are divided. I'm sure you remember what we said about monomials. Monomials are polynomials that have one term. So therefore, whenever two monomials are divided, situation case, the following: 4x cubed y squared z to the power 3 over negative 8x squared y 3z 5. Whenever two monomials are divided, what do we know whenever two monomials are divided? The show must go on. Division using what? SNL. Whenever two monomials are divided, division using SNL. SNL, whether it's like terms or not. Doesn't matter. Whether it's like terms or not, the show must go on. Division using SNL. So let's go step by step. This at the top is positive, this at the bottom is negative. So therefore division must happen using SNL. So the sign positive divided by negative, that gives us a what? Grade 9s. That gives us a beautiful sign that is, if you want me to, if I'm going to show the whole page, that means I'm moving further and further away. Okay, here, there it is, etzecho. All right. Yeah. So a positive divided by negative gives us a negative. All right. Good. Okay. Then sign is done. We move on to the next thing. What do we look at next? The number. 4 divided by 8. So when you have your calculator in front of you, because you want to make life very easy for yourself, you go ahead and you say 4 divided by 8 in your trusted scientific calculator, which makes life very easy. So I say 4 divided by 8. Though maybe some of you, your mental brains, your mental mind is fast and it's working, and basically you know exactly that 4 and 8, there's the highest common factor between the two. Between 4 and 8, the highest common factor is 4. So 4 goes into 4 how many times? Once. 4 goes into 8 how many times? Twice. So you have a negative 1 over 2. So the sign and the number are taken care of. Now we need to take care of the what? The letter. This is grade 9. The letter needs to be taken care of. So x squared, x to the power 3, division. We keep the base, we subtract the exponent. And you see the beauty in this is that, like I said to you, as per the grade 8 syllabus last year, you guys didn't know about negative exponents in grade 8. So what they usually said to you, or the advice was that if you are looking at same bases, top and bottom, the relationship is clearly multiplication between the bases at the top and at the bottom. Therefore, what you can do is you always take the smallest exponent, it joins the biggest exponent, and subtraction happens. Okay, so you're asking yourself, who's going to take who? Or you can go ahead and just apply the laws of exponents as you know it. Keep the base, subtract the exponents in that position. So here we have x to the power, but in the numerator, 3 minus 2. Y squared, y to the power 3. Y to the power 2 minus 3. Z to the power 3, Z to the power 5. Z to the power 3 minus 5. This is us applying our laws of exponents directly. All right. Then what do we get? Minus 1. We have there at the top x to the power 1, y to the power negative 1, z to the power negative 2. Everything is over 2. All right, so this 2 is the only one that is in the denominator. Everything else is in the numerator. Hence, I'm writing everything being over 2. All right, then last and finally, when we write our answer, negative x, okay, the 1 is there, okay, y to the power negative 1, that has a negative exponent. So what we know from what we have learned in grade 9 in term 1 when we're doing exponents, whenever a base is raised to a negative exponent and we want to write that base having a positive exponent, the base simply changes position, goes to the denominator, and then the exponent changes sign. Do you see that? Because our answer needs to be written in positive exponents. Once again, you have a z to the power negative 2 in the numerator. Whenever a base is raised to a negative exponent, the base changes position, goes to the denominator, and the exponent changes the sign. So our answer, all in all, when we write it, is what? It's negative x over 2yz. That is our answer. Okay. And this is so important, guys, because our answer needs to be left having positive exponents. We can't have a final answer where there are negative exponents. And what we are simply doing now is we are applying the knowledge that we gained in term 1. All right, when a base is raised to a negative exponent, we can write that same base in the changed position, not in the numerator but in the denominator, with the exponent having changed sign from negative to positive. Same thing with z to the power negative 2. We can write it as z to the power 2 just in the denominator. And that's basically finalizes our answer. Our answer is negative x over 2yz to the power 2. Let's not forget the exponent 2 that was there. You see, it's very important to make sure that we check that everything that was there is there as it was initially. All right, let's move right along. So hopefully we are all together when it comes to when two monomials are divided. What do? We divide using what? SNL. What does SNL stand for? We divide the signs, we divide the number, we divide the letter. That's what happens when two monomials are divided. Just like when two monomials are multiplied, what do? We multiply using what? SNL. What does SNL stand for? We multiply the sign, we multiply the number, we multiply the letter. And already let's remember that it does not matter whether the terms are like or unlike. Multiplication happens, the show must go on. So for multiplication and division, the show must go on. Case 3. For when addition and subtraction for two monomials, what is the deal? For when we have addition and subtraction for two monomials. So there's 3.1 where we have unlike monomials. If we have unlike monomials, in other words, 3x squared plus 5x, are these terms the same, grade 9s? Are these terms the same? No, of course. So if they are not the same, for addition, what is the answer? The answer is simply 3x squared plus 5x. We cannot add unlike terms. Let's look at B. 5x3 minus 2x squared. What about these two terms? This is a monomial and this is a monomial. We are subtracting it. When we subtract these two monomials, what is the answer? Can we subtract these two monomials, guys? Can we subtract them? Is it possible? Is it possible? Yeah, the problem is the exponency of our life. That's very true. That's the problem. So therefore, we know that our answer still remains as 5x cubed minus 2x squared, because we cannot add, and this is the important part, we cannot add, as you can see from the top, or we cannot subtract, as you can see from the bottom, unlike terms. It is not feasible. It is not possible. So we just make sure that we note that, and we note it without any hesitation. That's unlike terms. But let's look at these two examples. Situation 3.2. What about like monomials? What do we see with like monomials? 5x plus 3x. Can anything be done here with 5x plus 3x? CR for Life is saying 8x. What is everybody else saying? Okay, because I don't know how true that is. I don't know if even if Sia is actually saying the right thing here. I'm so confused right now. Bali is saying yes, it's for Amo just joined, and already she's jumping on the bandwagon and saying yes. And Lord M. Dandy is also like supporting something that I don't know if he's even sure about. He's saying 8x as well. Ribawona says 8x squared. Yeah. Sevilla says 8x. I'm not so sure if these people know what they are talking about. Ribawone, when you are wanting to be different from everybody else, you are saying 8x squared. I'm not so sure about whether you, right? So 5x plus 3x, guys, these are like monomials. In other words, they are like terms. So 5x plus 3x, what do we do with like terms? We keep the variable. We add and subtract the coefficient. I repeat, we keep the variable. We keep the variable. The variable is kept. We add and subtract the coefficient. So yes, those who said 8x, you are spot on. You are 100% spot on. We keep the variable x as it is. There it is. We add and subtract the coefficient. What is the coefficient? The number before the variable. So the number here before the variable is positive 5. The number here before this variable is positive 3. So what's 5 plus 3? 8. What is the variable that's supposed to be kept because it's like term? It's x. So the answer is 8x. So a round of applause to those people that said 8x. You guys know your stuff. Let us look at this one. Yes, Ribawana, you must be very careful. Let us look at this one. 5x squared minus 3x squared. What do the people in the gallery say? Ribawana, you must be very vigilant now. We can't afford to be making silly things now. You know, it's too late. This is grade 9, very critical grade. If you are going to decide to do pure maths next year, your teacher will say, hi, this one, I don't want this one because this one is not crops, not fresh. Yeah, you know, yeah. So we must make sure that we know our stuff. So we have 5x squared minus 3x squared. The question is, we are subtracting now. What is the deal here? The deal is the same. We keep the variable, we add and subtract the coefficient. So what is the variable here? The variable and its exponent is x squared. That is what makes these two terms like. So we keep that. Then we do what? We subtract the coefficient. The coefficient here is 5. The coefficient here is negative 3. So the $1 million question is, what's 5 minus 3? Guys, surely it's not even $1 million like. So therefore the answer is 2x squared. Okay. Hey, I hope we are flowing together, guys. So this is what we know we ought to do with like monomials. All right. Compared to what we did with unlike monomials, because unlike monomials we cannot add or subtract unlike terms, whereas like monomials we know that we can add them. How? We keep the variable, that is the same, we add or subtract the coefficient. Here there was addition, 5 plus 3 is 8. Here there was subtraction, 5 minus 3 is 2. No, and Lord M. Dandy, we do not subtract the exponents because we are adding like terms. We are subtracting like terms. You see, that logic, the one that you are saying, is incorrect. That is a misconception. Okay? We only, please take note of this. You see what I've written here? I'm writing this down for you. This is crucial notes. We keep the variable whenever we are adding or subtracting like terms. we keep the variable, we add and subtract the coefficient. That's what we do. Okay, let's not confuse the concept. All right, hope you are with me now. Can I see the word says when addition and subtraction? Okay, so when we are adding or subtracting like terms, we keep the variable, meaning we keep the letter, we add and subtract the coefficient. If it's addition, then we are adding the coefficients 5 and 3, 8. We keep the variable, it's x. If it's subtraction, we keep the variable x squared, we subtract the coefficient. 5 minus 3 is 2. Okay. All right, hopefully you guys are we're flowing together. We must flow. Okay, but if it's unlike terms, guys, you see x3, x squared and 5x, they are unlike terms. What does the rule say? We cannot add or subtract unlike terms. All right, guys, if you check out my slogan for maths is a game, I say maths is a game. Play it more frequently, get the distinctions, happiness. Maths is a game as well. Learn the rules, play it more often. You see, the thing is, these are the rules, guys. If these rules, you guys don't care about the rules of mathematics, if you don't care about these rules that I'm trying so hard to emphasize, then you guys are not going to do well in maths. You are going to be dissatisfied and unhappy, and then you are going to conclude that maths is a difficult thing that you don't like. You know, not liking something only comes when you don't know or you are unsure about the rules that you are supposed to be applying in a particular situation. So those notes that I wrote down there, take them seriously, guys, take them seriously. Okay, all right. I hope we are good. I hope we are good. Okay. I want to enter into something else. When I want to look at this one. When a binomial or trinomial is divided by a monomial. Very interesting thing here. Okay, so I'm just going to say, let's look at this for instance. Can you see what's happening here? Oh snap, what's happening here? What is happening? Okay, there we are. At the top, there are 3 terms. At the bottom, there is 1 term. Okay. And something you learned in the previous grade is that when you have something like this, in grade 8, you were told to split the fraction. Split the fraction first. So you would say A over D plus B over D plus C over D. All would be over D. A would be over D as one term, B would be over D as another term, C would be over D as the other term. One term in the numerator, take the term at first, over D, the second term over D, the third term over D. Then what you would do is you would then simplify each fraction as you see fit. Simplify each fraction, and obviously your simplification would involve division using S and L. You see? So you would split the fraction. This applies when here in this case we have 1, 2, 3. Trinomial is divided by a monomial, one term in the numerator. Okay, So you split first, okay? So you make sure that the splitting happens, the separation happens. Then after the separation happens, oh, Draco, thank you so much. Hey, I'm telling you, I think I'm off. That Draco in the flesh is such a, yeah, I don't know. I hope I'm not being inappropriate when I say you are a sweetheart. Thank you so much. I really appreciate the kindness. Okay, whether you are male or female, I would say you are a sweetheart. You know, sweethearts, they make people happy. They bring joy. They make people rejoice. So I really appreciate the gift, very, very, very much so. It's a very rare thing that happens on my life, so I appreciate when it does happen. I'm sorry, my learners, but I must appreciate. Thank you so much, Draco. I hope you are blessed abundantly and beyond, and more than anything else, where you have taken, may there be an abundance in your wake. Thank you so much. I really appreciate. Okay, so like I was saying, guys, we split. All right, whenever we have a trinomial 3 terms, or even if it was a, let's just look at another example. Even if it was a binomial over a monomial, we would do the same thing. All right, we split. Okay, we split. Then after splitting the fraction, we simplify each fraction using SNL, sign, number, letter. I hope you guys get I hope you get the feeling, the flow of this thing. So this is how we do things here. Now, you increase the number of terms. This in essence means if ever you have a polynomial, remember the word poly means many, and many is anything more than one. That's what many means. If you have more than one thing, then it means you have many things. Right? So even if it's 4 terms, 5 terms, 6 terms, and in the denominator you have 1 term, you must split the fraction first, and then you simplify each fraction using SNL. You divide using SNL because you know what you need to do when you are dividing using SNL, sign, number, letter. Okay. I hope we are in the same sort of like page here. Let me just maybe do an actual physical practical example of this thing here. Maybe some of you are like, I don't know if I quite get it. I don't know if I'm quite getting you, say, by what you are saying. Let's be practical. And 9z, let's say over what? Over 3. Okay. Let's say over 3z. So in the numerator, you can see there are 3 terms. In the denominator, there is 1 term. And this applies specifically to this case when a binomial or a trinomial is divided by a monomial. So maybe in other words, I can actually say when a polynomial, all right, because polynomial would encompass all more than 1 terms in the numerator, more than 1 term. Poly takes everyone into consideration. How often do I do live videos? I do live videos as often as occasion permits. As often as occasion permits. So like right now, I'm doing 1. So let's split. Do you see the splitting that's happening? Split. The split has happened. Now we are ready to do what? Divide. Using what? SNL. Let's go. Each individual fraction. Let's go. 4 divided by 3. That stays. That's still 4 over 3. It's x over 3z. No simplification there. Plus 3xy over 3z. 3 divided by 3. That's 1. X is in the numerator and then z in the denominator. Okay, yeah. Plus, hey, look at this one. 9 divided by 3. You see? So we are applying SNL. Positive divided by positive is positive. 9 divided by 3, that gives us a 3. And then Z divided by Z gives us 1. So in other words, we leave that as simplified as that. Look at that, guys. Okay? That's what I mean by split, divide using SNL. Split, divide using SNL. And this is only applicable when in the denominator you have one term, but in the numerator you have a few terms that are available. So hopefully that makes a bit more sense when you see the practical example of the actual concept that we have covered right there. So these are all algebraic sort of like rules, little rules that we need to always be considering. When we know them, it's nice. Term 1, you guys did squares, cube roots, all right, of an algebraic expression. Now I want to check when we have squares and cube roots of an algebraic expression. Okay, so generally speaking, x to the power n, if I say the square root of x to the power n, this here can be written in exponential form. Now I want to check if there's anyone that knows how do we write or convert this, who's in grade 9. How do we write this in exponential form? This becomes what in exponential form? This is the root of x to the power n. All right, so you guys did cover roots, squares, cube roots, and other roots and exponents. You should have done this, or at least you have an idea of this from term 1. The square root of x to the power n can be expressed as what? The square root of x to the power n. If I remove the square root, this becomes x to the power what, guys? Anyone know in the comment section? Anyone who'd like to actually request so that I can have a conversational sort of like interactive, they can help me out type deal? You can request, guys. I'll accept. You can join. I would love to talk and chat. Rather than have a speech. Shandu Khoma Khomza says n over 2. Very good. Kiyu says n over 2. Good girl. X to the power 1 over 2n. N over 2. Guys, this is the one. N, very true. Removing the square root. Guys, the square root, there's something that you guys don't know, but the square root implies that there's a 2 that is there. That's what square root actually means. So if you remove the square root, it's like you are taking the square root off, and then you are placing whatever value you have there, which denotes the root, as a denominator for the exponent that was already there. I hope you see this. So the square root of x to the power n is actually equal to x to the power n over 2. How important it is for you to know this. And this is also true as well, that the cube root then of x to the power n. Anyone dare lead me along and tell me what would be the cube root of x to the power n? Okay, so obviously we know that x will be our base still, but when we remove the root, the third root, which is the cube root, this becomes very true. I love this. I love the people in the comment section who are with me here. It becomes x to the power n over 3. Okay, are we feeling this? Are we vibing to this? So let's look at a practical example. The square root of x to the power 10 is equal to what then? The square root of x to the power 10. This is grade 9, guys. Term 2. We are jumping into term 2, like we are grabbing term 2 by the horns, you know. We're showing no mercy. Say nice. So the square root of x to the power 10 will give us x to the power 10 over 2. Very good. But we know that we can simplify this further. This is a fraction. What's 10 divided by 2? So that our answer can be as simplified as possible. That means our final answer is x to the power 5. Inside. Let's look at another. The cube root this time round of x to the power 18. What is the cube root of x to the power 18? The cube root of x to the power 18. We can write this in exponential form first, then we write the final answer. Obviously, writing it in exponential form first, converting the root to exponential form, then from exponential form, simplifying it. So this is exponential from root form to exponential form to the answer. So cube root of x to the power 18. Will give us x to the power 18 over 3 indeed. Then when we simplify, yes, diprose, as you said, it's x to the power 6. So I am saying these are very useful rules. The rules on squares and cube roots of an algebraic expression. Know these. Okay? Know these. These are very important. Knowing how to convert root to exponential form. Okay? Knowing how to convert root form to exponential form, and then ultimately the answer. Okay? These are all important rules for algebra. Hey, if these rules are known very well by a learner, the learner just has a field time in this grade. Here's something else for your importance. A negative sign raised to an odd exponent. A negative sign raised to an odd exponent. So for example, -1 raised to the power. If a negative sign is raised to a negative exponent, what is the outcome? What sign do we get as an answer if a negative sign is raised to an odd exponent? What is the outcome? Case viewer, like you said, it is negative. The outcome will always be negative if the exponent is odd for a negative sign. So applying a odd exponent to a negative sign leads to a negative result. So for instance, the -1 to the power 3. Remember, when we apply the exponent, we don't only apply the exponent to the number. We apply the exponent because the exponent is outside the bracket where inside we have -1. This means that the odd exponent must be applied to the sign and the odd exponent must be applied to the number. So this SNL idea is also coming into play here. All right, someone's playing some glorious music outside. So the odd exponent applied to a negative sign means we have a negative answer. But 1 to the power 3 is equal to obviously 1. So that is the sign, that is the number. The application of that into that. Okay, Let's look at something else. What about a negative sign where an exponent is even? What does that lead to? What outcome? What sign? If we are applying a even exponent to a negative sign, what is the result? What sign do we get as an outcome of applying a even exponent? Okay, very true. We get a positive. Okay, very important, guys. Very, very important. All of this is so important. So for instance, if you have -1 squared, for instance, our exponent is not only going to be considered for the number, it's going to be considered for the sign as well. Okay? So very importantly, we apply the negative sign exponent, the even exponent to the negative sign, it becomes positive. And it's positive what? Positive 1. Okay? So these are important things, guys. It seems like little things, but they're very important. Remember, 1 squared, 1 times 1. 1 squared is 1 times 1, so the answer is 1. It can't be positive 2, tsecho. Just be very careful of that. Otherwise, it will really mess us up when we have that, you know. Okay. All right. You typed too fast. Okay. So let's look at some of these exercises here. Me has some exercises for you. But before that, here's something interesting. I just want to check. 3 plus 5. The whole thing squared. Can someone let me know how would we do this problem? 3 plus 5, the whole thing squared. What would we do here? Okay, Ribawana says it's 64. But like, let's say we were to apply ourselves step by step. What would we first do? Okay. I hope you guys, when you're looking at this, you are immediately thinking about this guy. I hope we are thinking of this guy. Bad mess. What does bad mess stand for? B stands for brackets, E stands for exponents, D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. That's what bad maths actually is. Brackets, exponents, division, multiplication, addition, and subtraction. And we always follow this order whenever we are looking at something and it has multiple operations. So I hope all of you logically sort of like look at this and you're like, okay, we have brackets here, but we have an exponent. So typically we would want to start with the brackets. Then we actually look at the exponent. So if we look at the brackets, we can clearly see that there is a 3 plus 5 inside the bracket. These are like terms. You can add these two numbers together. Brackets. You see? So that's what it helps to actually know bod mass or bad mass in this case. So 5 plus 3 is 8. Then 8 squared is like saying 8 times 8, which is 64. Right? Yeah. Guys, I hope I never see any of you do the following. This is very dangerous. If you would have said you apply the square to the 3 and then you apply the square to a 5, this is totally wrong. Okay? Because we don't do that where there's a plus And in actual fact, we don't do that where there's a plus. We don't do it where there is a minus in between two terms. Okay, very, very important. Okay, so let's always ensure that we do not in any way find ourselves falling into the trap of applying the square to the respective numbers. We don't do that. It's wrong. Why? Because it does not follow the format of what? Of bad math. All right, and plus we cannot, I mean, think about it. Let's say, okay, you go ahead, you do this error. What's 3 squared? It's 9. What's 5 squared? It's 25. What's 9 plus 25? It's 34. Is 34 the same thing as 64? No, it isn't. So that goes to show you that this year, okay, so whenever there's addition or subtraction and there's an exponent on the outside, we do not apply the exponent to each respective term. I usually tell my grade 9s at school that this is absolute nonsense. And in actual fact, when we write the notes for my learners, when we write down the notes, we write it down that we actually do the problem that's like this, and then I know most of them initially they will say this is correct, and then I bring out the point that, hey guys, this is absolute nonsense. We don't do this thing. We must make sure that we don't ever do this thing. All right, so it's something that we need to be vigilant and very much aware of. So yeah, just something to note for the future and for the future and for the future and for the glorious future. All right, okay, so I am going to give you some because yesterday we looked at this. I'm going to give you some work now. All right, I'm not going to continue any further. I'm going to give you some few exercises to consider. The expression here, the expression 2x squared minus 8xy minus 9y squared plus 7. I did say I'm not going to keep you for long. An hour should be enough. I also need to scoot now and go and do something else. So 2x squared minus 8xy minus 9y squared plus 7. Okay, this is sort of also still revision from grade 8. And what I want to ask first in this expression is how many terms in the expression? How many terms in this expression? Okay, please flood my comment section with the answers. I'd love to see how brilliant the people I have on this live actually are. Bongi, I see you. I see you, Sviwe. I see you, Zintle, J-Cheese, Reba, Mbali, Tseho. Okay, I surely hope that people are not just blindly following what has been commented, but you know how many terms there are based on your understanding of how to identify terms when they are given to you. So what separates terms? We know that what separates our terms is a plus and a minus sign. And we also know what combines terms. Multiply combines terms. Divide combines terms. Having a bracket combines terms. So in this situation, 2x squared minus means separate. 8xy is the second term. Minus means separate. 9y squared is another. Plus 7 is another. So that means there are 1, 2, 3, 4 terms. So you guys are you are 100% spot on. Very good. Let's look at the next one. Number 2. I want you to state the coefficient. I want you to tell me the coefficient of 1 x squared. What is the coefficient of x squared, guys? The coefficient of x squared. The coefficient of x squared. What is the coefficient of x squared? Okay, I see people flooding the comment section. I see you. Sandla, Blissful Lady, Reba, Mbali, J-Cheese, Siviwe. Okay. Miss Ladla. Okay, You guys are 100% spot on, all of you. I'm very happy. It's definitely 2. All right. And it's a positive 2. The next one, what is the coefficient of y squared? What is the coefficient of y squared in this expression? What is the coefficient of y squared? Okay, I see people and their comments. The coefficient of y squared. Okay, so here we have people that have different answers. Mbali Sandla, Geswani, Bongi Siviwe, Zintle have the same answer. And Mam Charlie. I see Riba changed his answer now. Okay. Right, and then we have someone who has different. Mam Charlie initially said 9 but changed her answer. Riba had 8, now changed his answer as well. Okay, it seems like we are all agreeing now. Please guys, let's not forget that whenever we write the coefficient, the sign must also tag along. We don't leave the sign behind. You must take the sign into the party as well. You don't leave the sign behind. Okay, see, people are leaving the sign behind. They want to enjoy alone. All right, next, state the coefficient of x. The coefficient of x. The coefficient of x. Okay, Riba has typed there. Can see Riba's answers. Yvonne, I can see your answer as well. Severe, I can see your answer as well. But I see it's been... Yeah, let's reveal it. I can see your answer as well. Who is this fire extinguisher person here? Fire extinguisher, Aluncedo. Oh, I see you there. Riba, I see your answer, the renewed answer. Okay. The coefficient of x. This is very deliberate. I said the coefficient of x. Okay. Bongi is saying we don't have, sir, we have xy. Hey, Bongi was not here yesterday, right? Bongi, you were not here yesterday, right? In our lesson. Okay, you can see the people that were here yesterday in the lesson and the answers that they have chosen to write down. The coefficient of x, guys, is negative 8y. Negative 8y. Negative 8y. You remember what I said yesterday about the coefficient? I said to you that yes, in principle and in the definition, we say it's the number that is multiplied by the variable. But if I'm going to say to you what is the coefficient of x, you go to the term that has x in it and then you identify what's next to the x. So it's negative 8 and the y that are next to the x. So we write all of them. Negative 8y. That is the coefficient of what? Of x. Right? Next question. What is the coefficient of y? Come on, let's see. Let's see if people can redeem themselves in this one. What is the coefficient of y? This is the time for redemption. The coefficient of y. Okay, I can see people are redeeming themselves there. Coefficient of y. Coefficient of y. Coefficient of y. Right? So we go specifically to the term that has y. All right? This is the one. This one is 9y squared. All right? So we don't come here. We come here. The coefficient of y. So the y is here. What is the coefficient of y? You guys are spot on, the people that said it's negative 8x. Okay? Our eyes don't even go in this direction. We don't even consider this one. This is not y. This is y squared. Okay, this here is y. The coefficient of y is negative 8x. What is multiplied to the y is negative 8x. So we write the entire thing. Right. I love the people that have actually sort of mastered this, and they can see. Determine the value of the expression if x is equal to 2 and y is equal to negative 1. I'm going to rewrite the expression. The expression was 2x squared minus 8xy minus 9y squared plus 7. This is the expression. I want you to determine the value of the expression if x is equal to 2 and y is equal to negative 1 of this expression. What is the value of the expression? Right, so this is just also another question that I'm sure it's not new. Okay, someone want to tell us in the comment section, what would we do to find the value of the expression if we are told x is equal to 2 and y is equal to negative 1? What would we have to do to answer this question? Ribona, you can go ahead and tell us. You can breathe. Okay, substitution. Substitution. And when we substitute, guys, what do we use? Okay, I like the fact that Ebongi says we substitute the x value in the expression. Very true. We substitute the x value in the expression, but not only just the x value, but as well as the y value. You can see that Alungedo there helped us out as well. You can see there is Alungedo's substitution. Okay, that 2 into, in the place of x, we substitute what? 2 in brackets. Very important that we use brackets to substitute. Okay, Alungedo substitution, I'm sure you guys can see it there. Okay, but slightly slight error there from Alungedo, because 8xy, remember, minus 9 the y minus 1 the whole thing squared plus 7. Okay, so this is what we do. We substitute in the place of x the 2, and then we substitute in the place of y the negative 1. So you can see that everywhere where x is, I've substituted what? 2. And everywhere where y is, I've substituted negative 1. And what have I used as I have substituted? I've substituted using brackets. Very key. This alone, substituting using brackets, is mark worthy. It's marks, that one, guys. Marks for days. Okay, and then you guys learned how to simplify, for days. This 2, remember bed mass, very important that we remember bed mass as we work towards the simplification. 2 squared, obviously, brackets exponents, the 2 weights, this 2 must wait for the 2 in the brackets to be applied with the square. Okay, very important. So that means 2 squared is 4. You see the brackets are retained there. I hope you can see that. Negative 8 brackets 2 brackets negative 1. 8 times 2 times negative 1. But the signs, please guys, negative times a positive is a negative, and then a negative times negative gives you a positive. What's 8 times 2? 16. 16 times 1, that still gives us 16. Very important. Minus 9. This negative 1 squared gets priority. We don't multiply the negative inside when this exponent is there, because bed mass, brackets exponents, brackets the exponents, then the multiplication of the negative 9 with what we get as the result. So negative 1 squared, you remember what I said about the even exponent with the negative sign? It changes it to positive. So we have positive 1 there. You see? Plus 7. Now 2 times 4, that's 8. Plus 16, negative 9 times 1, that's negative 9. Plus 7. From here, it's easy. We've taken care of the brackets, we've taken care of the exponents. There was no division. Multiplication was taken care of. Now we are free to add and subtract. Okay? That's very important. Very, very important. Okay? So very, very important. Yes, you can do that too. Okay? Because multiplication is commutative. So 8 plus 16 minus 9 plus 7. Surely, guys, the beautiful answer that you get at the end, which I'm sure you all have in your heads, is okay. Blissful lady Siviwe released us from prison and gave us the answer. Okay, right. Okay, now me is going to, I think I'm probably going to end this one now at the time that I thought I wasn't. So I think I'm enjoying this a little bit, and it's because of you. Here we are, guys. Simplify. Okay, this is m cubed plus 3m cubed plus 4m squared. So when we have an expression such as this, you can see there's addition alone. So what do? We need to first look like terms. Okay, we need to identify the like terms. When they are there, we know like terms we can add, but unlike terms we know we can't add. Okay, so he is like him. Why? Because their variable and exponents are the same. He is unlike him. Do you see that, guys? Remember what determines like terms? The variables must be the same, but also the exponents as well must be the same. Okay, so what does that mean? We can add these two, but can we add these two with this one as well? No, because this one has a variable and a different exponent. So like terms can be added. What did I say when we add like terms? We keep the variable and its exponent, so m cubed for these two, and then we add the coefficients. What is the coefficient that we don't see here? It's 1. So what's 1 plus 3? It's 4. Okay, and then plus what? Plus 4m squared. Is there anything more we can do here, guys? I usually know when grade 9 learners don't really, I know when to know when a grade 9 learner shouldn't go to grade 10 and do pure maths. When I know, what makes me know that a grade 9 learner will have a very difficult time doing pure maths in grade 10 is when they fail to leave the answer in this stage. Okay, when you have failed to understand the little rules in earlier grades, then it affects you when you move on to the next grade. So these are crucial rules. They are, I don't know how to overstate this. Okay, Bongi, the question was saying simplify, all right? It did not say factorize. So we leave the answer like this. This is the simplified answer. All right? Yeah. Unless in this question they had said to us, simplify the following and then factorize. Then, yeah, of course, we would have simplified, then at the end factorize. But no, they didn't say that. The question simply says simplify. Okay? So we leave it like that. Okay, 2. So my question to you, are you a potential grade 10 maths learner who can do pure maths or not? You see, those are serious questions you need to ask yourself. Okay, right here. Okay, yeah, Litemba, the truth here is that we don't factorize because the question said simplify. You know, this is grade 9, guys. Grade 9 term 2. 4m squared n minus 7m n squared. Are these like terms? Because if they are, then we can proceed and go on. but here 4m squared n minus 7m n squared, are these like terms? Okay, so people are saying no, right? Why are they saying no? M is raised to the power 2, m is raised to the power 1, so these are unlike terms. So ultimately this is the answer. Thank you very much. 3. Right, I hope you guys are really now. Can I tell you this? The assumption for any grade 9 teacher who's accepting you in term 2, any grade 9 teacher is thinking that you guys already know these. The thing is, all of what I'm doing here is not the new work that you do in grade 9. It is the old work that you did in grade 8, which you need to come into grade 9 knowing very well. Okay, so that's why I'm trying to catch you up. If you were not sure, you must be very sure, 100% sure. So in this situation, what relationship? So here in this situation, in the first question, the relationship between the terms was addition. So we had to look for like terms. That's why like terms was important. Here as well, the relationship is subtraction. We had to look for like terms, but we found none. So we don't do anything because we cannot add or subtract unlike terms. What about here? M squared n brackets 7m n squared brackets 3m squared. What do brackets mean in algebra? Brackets mean what? What is your understanding? Brackets mean mbali says multiply. Alone. Mbali is the star. Khali says, Tsepo says multiply. Multiply. Okay, so yes, brackets mean multiply. So what are we saying here? We need to multiply. Is this and this and this like terms? No, it isn't. But you remember what I said earlier on. I said for multiplication, whether it's like or unlike, we multiply. But when we multiply, what do we need to take into consideration? I said we multiply using S and L. We multiply the sign, multiply the number, multiply the letter. So this and this and this can be multiplied. So let's start there. This is positive. This is positive. This is positive. A positive times a positive times a positive. Positive times a positive is positive times another positive is positive. So the answer will be positive. That is the sign. We are done. Let's go on to the number. The number here is 1. The number there is 7. The number there is 3. Let's multiply the numbers. 1 times 7 is 7 times 3 is 21. We are done with the number. Click. We move on to the letter. Letters of the alphabet. M, M, M. M squared, M, M squared. When we are multiplying same bases, the laws of exponent, the rule that applies to exponents, we keep the base, we add the exponents. We know there's an exponent 1 there. Don't forget it. 2 plus 1 plus 2. I'm just writing it out, guys, so that you can see what I am doing. All right. Maybe someone else will go ahead and just say they know the bases are the same. You are multiplying, so you keep the base, you add the exponent. So someone else will just write m to the power 5 from the get-go. I am writing it out so that you can understand what I have done. That is the letter M. Let's move on to the letter N. What about the letter N? There's an exponent 1. There's an exponent 2. There's no N here. So that means I'm going to say N 1 plus 2. Then what does that give me? Siviwe initially commented there in the comment section and said the answer is 21m to the power 5 n to the power 3. What just happened here? I multiplied 3 what? Monomials. Okay, multiplication of monomials. How do I multiply monomials? Grade 9. You multiply using SNL. You multiply the signs of the 3 monomials, tick. You multiply the number coefficient of the 3 monomials, tick. You multiply the letters of the 3 monomials. Keep the base, and remember, when you are multiplying the letters or the variables, you keep the base, you add the exponent. So that's very important. Final answer is 21m to the power 5, n to the power 3. Very key. Okay, all right. So yes, I hope that is very, very clear for one and all. All right. This should be very interesting. Let's look at this. This should be very interesting. Okay, if you look at the first one, it was just addition alone. We had to identify like terms, add the like terms, can't add the unlike terms. If you look at scenario number 2, there we had subtraction, but we could clearly see there's no like term, so we did not do anything. We left the question as the answer as it is. Here, there's multiplication between 3 terms. So multiplication of 3 monomials, means we multiply using sign, number, letter. Look at this one. If you look at this expression, oh, by the way, in the first expression, how many terms were there? There were 1, 2, 3 terms, 2 of which are like terms. That's why we added them and we were able to get an answer of 2 terms. The second expression, how many terms are there? There are 1, 2 terms, but these terms are unlike terms, so we could not add them or subtract them. We left the answer as it is. 3, if we look at this expression, how many terms are here? That's a very good question. How many terms are here? Now, someone in the comment section did indicate that we consider, it was Aluncedo, said we consider all these expressions as one term. Why do we say it's one term? It's because of the fact that the relationship between these is multiply all the way through. So we consider this as one term. Okay, so in each bracket, we just multiply each individual term with the other so that we can get the answer. Now we are here. 2p minus 4p brackets 2p squared minus 1 close brackets. I want to ask this question. How many terms are in this expression? Let's start there. How many terms do you see in this expression? How many terms do you see in this expression? Tseho says 4. Ntlamolo says 3. Sosh says 2. It's like we are going down. 4, 3, 2. Sosh says 2. Bongi says 2 or 3. Now, Bongi, you are the most dangerous because we can never say 2 or 3. You must be very specific. You must give me one number, not 2. You know, that says to me you are unsure, and we need to be sure. Emihle says 4. Mia says 2. Chiza says 2. Chiza man. T says 3. Mbali says 2. Sandra says 1. Letiwe says 3. Shedo says 2. Tango says 3. Okay, we've got many answers here, which is very concerning. All right, we've got many answers, which means, guys, that's where I start saying, we can surely say that some of you are going to be struggling because it means the basics are not understood. All right? Right? Now I need to go back for the purpose of those people that don't understand the basics, because I established a few things yesterday. They were very strong, those things I established. So I'm going to relook at this again. Guys, please. A term in algebra is a combination of numbers and letters. This is something that I covered yesterday. And I would advise you, I would really encourage you to go to my YouTube channel and check out the video that I did of this particular section. But I'm not going to go into it because I covered it in the channel. So you can always go, please. I have a link in my bio. Maths is a Game 5 to 7. That is basically the name of the YouTube channel. Link in my bio, you can go on there. I will be uploading the video of what I did yesterday. But look at this, guys. What separates terms is a plus and a minus sign. But there's also things that combine terms. So for instance, 2p is one term. It's alone. It's alone, this guy. Alone. This minus sign acts as a separating agent. Then it separates what? 4p, but there's brackets here. And brackets do what? They combine the terms. So yes, inside this bracket there are two terms. But because of this bracket, do you know what happens? Because this bracket is here, this here becomes 1. This here is called one term. 2p squared minus 1 is one term. Why? Because of the existence of the bracket. This 4p has a relationship with the bracket of what? Of multiply. So this makes this whole entire thing one term. This is my second term. Hey, I hope you guys are with me. So in essence, go back to the question I asked in the beginning. How many terms are in this expression? If you are answering me well and you've just listened to what I explained now, you are going to say how many terms are in the expression. There are 1. The minus sign separates. There are 2 terms. And the reason why it becomes 2 is because of this bracket. This bracket makes 2p squared minus 1 become 1. And then the relationship of the bracket with this 4p is multiply, which then makes this term here become 1. Because multiply combines terms. It does not separate. So how many terms? 1, 2. Okay? This helps me. Hey, this helps a lot. That is why then your answer, when you are doing this problem, you are going to look at 2p on its own. You cannot say 2p minus 4p. Why? Because this negative 4p is combined. It's combined to what? To this bracket. It's like this 4p is married. Yay, guys, it's married. This 4p is married to this bracket. You can't combine, you can't say 2p minus 4p. You can't try and separate this 4p and you say 2p minus 4p. You say, no, this 2p and this 4p are like terms. I'm going to say 2p minus. No, you can't. No, you can't. All right? So this is very important. This idea of understanding your terms is so important because it will then help you with your simplification. But if you don't have this awareness of how many terms in an expression, you are going to have some challenges, serious challenges with algebra. And then you are going to say maths is a pain. But it's not. It's just that there are basic things that you don't take seriously. Okay? So 2p, we write it down. This negative 4p, if you remember, there's a property in numbers in grade 8 that is called the distributive property. It applies when you have a monomial outside the brackets and inside you have either a binomial, trinomial, or polynomial. You distribute the negative 4p to the 2p squared. How? By multiplication. Why by multiplication? It's because brackets mean multiply. So you are going to take negative 4p and distribute it to 2p squared. Then take negative 4p and distribute it to negative 1 so as to remove the bracket and simplify. Okay, very important. So let's do this. Negative 4p times 2p squared. Negative 4p times 2p squared. What's a negative times a positive? Because when we multiply, we must remember S and L. So what's negative times a positive, guys? It gives us a negative. Then what's 4 times 2? It's 8. What's p times p squared? Bases are the same. We are multiplying, so we keep the base. We add the exponents. So yes, Bongi, it gives us p to the power 3. 100% spot on, Bongi. And Sef. And Sosh. We are done with the distribution of negative 4p to 2p squared. Then we take that same negative 4p, we distribute it to negative 1. Do not forget to consider the sign as you distribute. That's why, guys, I'm insisting on multiplying using S and L. S and L. I'm sure you've seen these letters in a movie when you watch a movie that you're not supposed to be watching, which is very inappropriate because it's rated in a way that is scary, that you shouldn't be even entertaining. S and L. But the S and the N and the L stand for sign, number, letter, sign, number, letter, sign, number, letter. So when you are watching a movie, it's inappropriate. Drop the remote, turn off the channel, stop the video, go and do some maths, apply S and L and get it down nicely. Negative times a negative, guys, is positive. Negative times a negative is positive. 4 times 1 is 4. P combined with the number. Now, guys, I'm sure you can see. After the distribution, I can see 3 visible terms. And in those terms, you can clearly see that there are like terms that you can take care of. So, negative 8p to the power 3, leading the terms as expressed, is followed by a positive 2p, because this 2p is a positive 2p, plus a positive 4p. Let's add these like terms that we have brought close to each other and then write down our final answer. The final answer is negative 8p to the power 3 plus 6p. Finito. Comprendo. Magnifique. All right. So all that this guy that is here is doing is just bringing a bit of sensitivity to the maths, the rules. Don't we hate rules? We do. That's why some of us, we flunk the maths, or we don't do as well as we should. That's why some of us, we are still not getting the level 7. Some of us, we are lying there in mediocre stage, level 5, level 4. We know we could be attaining more, but it's just that the rules are not, we are not 100% with what we are supposed to be doing. But the minute, I'm telling you, the day you guys are with the rules and you know what you should be doing in a particular situation, because you have a sense of awareness, you are looking at this, you're like, oh, these are the steps that I should be taking. That day when you are sorted.